the second learning target video. Um, our second learning target for our first unit is to evaluate competing designs for energy production and develop a sustainable plan for energy production. Um, so to fully understand this learning target, you need to understand all the different ways that we generate electricity. So through biomass, solar, hydroelectric, how do we convert those energies into electrical energy? You have to understand some good things and bad things about each one, and then the way all the goods and the bads of each to come up with a sustainable energy plan. So in our packets, we were filling out page 8 is kind of like a one page of all the different energy resources, whether it's renewable or non-renewable, and generally speaking, how we make electricity from it. Then we kind of looked at how do we compare two different energy resources. For example, solar doesn't really cost a whole lot to have one solar panel, or the same thing with a windmill. But at the same time, it doesn't really cost that much. Or I'm sorry, it doesn't produce that much electricity. But if we look at something like nuclear power, to make one nuclear power plant is incredibly expensive, but also makes a lot of electricity. So how do we compare things that cost different amounts and produce different amounts of electricity? So what we do is we use something called the levelized cost, and basically we take the amount of money it takes to produce electricity and divide it by how much electricity it makes. So on page 9, we replace this page with a more detailed page, but it's essentially the first page is kind of the same. We can see that coal costs $95 per kilowatt hour. Natural gas is only $73 per kilowatt hour. So natural gas is cheaper than coal. Nuclear is about the same as coal. Wind in windy places can be cheaper than both of those. And then we can go down the list and see the rest. We see that solar is pretty expensive. Geothermal is really cheap. So part of understanding our sustainable plan for energy production is understanding the cost, so the monetary cost, but we also have to understand the costs to the environment. So for example, wind and coal, or solar and nuclear, not only cost different amounts of money, but they actually have different costs to the environment. So what we're going to do next is we're going to go through each one of the energy resources and kind of explain in detail how we make electricity. Is this energy a clean source of energy? Is it cheap? So really we're just looking at the levelized cost. And then each of them are kind of unique in their own way. So what can we understand about each that is unique? So to access that information, if you go to my website and then click on energy resource details, this is a PowerPoint that we went through in class. And we pretty much skipped through the first few pages of slides because that was all kind of review. And then we got to biomass, and then this blue slide after the first initial slide kind of gives all the information we need. So for biomass, this is a thermal energy source. We burn something. In this case, it's garbage or old plant material, something that was going to go to waste anyway. We burn it, and then that obviously boils water to make steam. So in terms of whether this is clean or not, this is most definitely not clean. It produces carbon dioxide and anything else that may go into the air when we burn things. It is a moderate in terms of the levelized cost. It's not the most expensive, but it's not cheap either. And then what's unique about this one, so if this one makes pollution and it's not the cheapest, then why would we do it? Well, it's taking stuff that was going to rot or be thrown away anyway. So instead of letting it rot and putting carbon dioxide back into the atmosphere on its own, if we burn it, then we can generate electricity from it. So one upside to biomass is even though we're still burning something, it's carbon that was likely going to end up into the atmosphere in a relatively short time anyway. So biomass is not as bad as fossil fuels, because fossil fuels are taking carbon that was locked away, probably never going to come back into the carbon cycle again. So that's biomass. Coal is a fossil fuel. This is one that we burn, and we burn it to boil water to make steam. It is definitely not clean. It makes carbon dioxide and other stuff that goes into the air. This one is a moderate one. It's depending on the source, some people consider it fairly cheap and inexpensive. It can become expensive, especially if you try to capture the carbon that comes from the power plant. So altogether, we kind of put it in the moderate category. And then something unique about coal is mining coal is actually bad for the environment. We talked a lot about mining in our third learning target. So coal is actually, from start to finish, really bad for the environment. The mining process isn't great for the environment, the burning it, and then afterwards we've got ash and other waste that we have to deal with. So when we're done with coal, it's still bad for the environment. So it's moderately cheap, which is its appeal. But in terms of the environment, it's not a great one. Geothermal. So geothermal works by taking cold or normal temperature water and pumping it underground near a heat source, and then allowing the steam to come back up, spin a generator. So this is a thermal energy, but we're not burning anything in this one. We're just capturing heat from the ground that's already hot. So this one's very clean. We're not burning anything, so there's no real pollution or waste. There may be some problem with pumping water underground, but generally it's not considered bad for the environment. It's really cheap and efficient. There's very little energy input on our part. And what's unique about this one is it can only be done near places that have magma near the surface, so volcanoes or hotspots. Otherwise, we can't really generate electricity from it in places that don't have that. So in Michigan, we don't really have any of those things, so we can't use geothermal to generate electricity. There are other types of geothermal that you can use to heat or cool your home, but we're talking about electrical generation, so Michigan is not really geothermal rich, I guess. The next one is hydropower, so hydroelectric dam. This one's pretty simple. We just stop a river and allow the water to flow through our turbine, and that turbine spins a generator. So we are capturing the motion of water that's already moving. So for the most part, this one is considered clean. We're not burning anything. It doesn't really make pollution or waste. So generally speaking, this is considered efficient to moderately efficient. The hydropower plant is fairly expensive to build to begin with, but once it's up and running, then it's pretty moderately inexpensive to keep going after that. What's unique about this one is it's only built on water, so we can't just, Arizona is not a great place to have a ton of hydroelectric power plants. And obviously, if we put a wall on a river, it's going to create a lake, and that greatly alters the environment. It's bad for the things that want to travel up and down the river. So hydroelectric power plants, while they're generally considered clean, they're not all that great for the environment either. So another downside to hydroelectric power is that we're basically tapped out. Every place that we can put a hydroelectric power plant, we probably have already put one. There's very few places where we could add one, or it's not going to significantly alter where people are currently living. We're going to skip the pump storage for, that was one that we talked about in class, but it's not one that we're going to talk about much. The next one, natural gas, petroleum, and propane. We're going to lump all three of these together because they're pretty similar. This is a fossil fuel, so we burn it. Anytime we burn something, we're putting carbon dioxide and other pollutants in the air. So this one is very cheap. That's one of the cheapest ones. And what's unique about natural gas is of all the fossil fuels, it actually does burn the cleanest. It does make pollution, but less than coal or oil, and also puts the least amount of CO2 in the air. Petroleum is pretty similar to natural gas. We burn it, makes pollutants. It's moderately cheap. We use it for heating, but we actually use petroleum for making stuff out of plastic. So we use petroleum for a lot of different things. Not really electrical generation, but it can be. Propane is pretty similar to the last two that we just did. We burn it, make some carbon dioxide and other pollutants, moderately cheap or inexpensive, and we use it for heating. And you probably have a propane grill in your backyard, so we use or can use it for cooking. So that's propane. Solar. So there's two different types of solar. There's photovoltaic solar, which is where we take a panel, and that panel directly turns it into electricity. So I call that direct transfer of energy to electricity. They're starting to develop glass that can do the same thing. So pretty soon in the future, our glass skyscrapers will be, solar power plants. So that's one type of solar power. The other type of solar power is done with mirrors, and this is taking the infrared radiation from the sun and pulling it all into one spot. And so this is considered a thermal energy source. We're taking the heat energy and concentrating it and using that to boil water to make steam, a lot like our other thermal energy resources. So when we talk about the process of making electricity, we've got two different categories: thermal, which is using mirrors, or the photovoltaic, which is a direct transfer of electricity. Both are considered pretty clean. Neither make pollution. We're not burning anything. Neither of them are considered cheap, though. The thermal power plants are most, when we do the levelized costs, are the most expensive. The solar panels, photovoltaics, are coming down in price. They're still pretty expensive, especially if the farther away from the equator you live, the less direct sunlight you get. So for Michiganders, solar is not really the cheapest. Hopefully it will be at some point, but now it is not. So what's unique about solar is that it's not super reliable. If it's not sunny out, cloudy day, or nighttime, then we don't generate any electricity. And one thing that we looked at is we looked at wind and solar energy are on average produce the most, and our demand, and they don't really match up. Our biggest demand is in the evening, and that's when we have very little sunlight to no sunlight, and it's often the least windiest time of the day. So there's a big problem with solar and wind, in that it's not produced when we need it. So there's kind of a storage problem, which is a separate issue from what we're talking about. The next one is nuclear fission. So basically this works by having a bunch of radioactive material in one spot that generates heat, and then that heat boils water to make steam. And then we use that steam to spin a turbine, which spins a generator. So this one we're not burning anything. It's probably the thing that people get wrong the most is they think we're burning nuclear radiation. We're not. We are collecting the heat from it. After it goes through its nuclear reaction, it gives off a lot of heat. So is this one clean? This one's kind of in the middle. So the actual process of making electricity produces no carbon dioxide, since we're not burning anything. As long as nothing goes wrong, it's considered pretty clean. Afterwards, we do have radioactive waste that we have to deal with. That's going to be radioactive for potentially millions of years. So that's a problem. But the actual day-to-day operation of a nuclear power plant is pretty clean. So this one is incredibly expensive, but it makes an insane amount of electricity. So together, its levelized cost is in the moderate, in the middle somewhere. What's unique about a nuclear reactor is that obviously there's danger of melting down. Chernobyl is the most famous example of a nuclear power plant that melted down. It blew up, and the entire town, many people were killed, and the town is now a ghost town, and it's still highly radioactive. Another problem with nuclear power plants, as we mentioned already, is the waste has to be stored. And another potential problem is that it needs a large amount of water to operate the plant, more than most thermal power plants. So you need like a lake or river, a large river. Um, there has to be a steady source of a lot of water. So that's another potential problem. And then since most people, most of the world's population lives near large bodies of water, that creates a potential hazard with meltdown. So generally speaking, it's a good one, but has some huge risks. And wind is the last one we'll talk about. Similar to solar, it's not super reliable. The way we generate electricity from it is by capturing the motion of wind. That's generally considered clean. There's no pollution that's being made. There is some types of pollution, sound pollution and light pollution, that are made from wind. Windmills are really noisy. If you've ever stood underneath one, you know how noisy they can be. And then if you live in between a windmill and the setting sun, you'll know the flashing light that it makes is kind of irritating. So it's also considered to give off some light pollution or visual pollution. It's generally considered kind of cheap, as long as you live in a windy area. Some places are not very windy, so not really be an efficient energy source there. So this mostly depends on location. And what's unique, like solar, like we mentioned, it's not reliable. It's not a windy day. You don't generate electricity. So that is all of the energy resources that we talked about. There are other ways to generate electricity, like waves and tides, fusion power, but we don't have time to talk about those. So, that is it.